Good morning, everyone. Thank you for joining our webinar. I wanted to let you know we will get started promptly at 11. You can see that we have a lot of attendees joining, so just hang tight for a few more minutes and we will get started right at 11. All right. Good morning to all of our guests from the U.S. who are joining us. It's a brisk, clear day in Knoxville, so we hope everybody is having good weather. Good afternoon to our international Hoffman Group colleagues that are joining us actually from all over the world, mainly from Europe. But I see that we have one very dedicated colleague in India, and I think it's around midnight there. So thanks to her for joining us as well. My name is Ashley Humphrey, and I'm the Director of Marketing and Communications for Hoffman Group USA. I'd like to welcome you to our first ToolScout 101 webinar. We are very excited that you're with us today. Today, we're just going to briefly go over the basics of this online tool to give you a high-level overview of its features and how it can help you find the right tool for pretty much any application. But first, I want to give you a couple of rules for the webinar, just some things to remember as we move forward in the presentation. Everyone has been placed on mute when you come into the webinar, and I would like to ask that you stay muted throughout the presentation. That just helps us avoid background noise and distractions during the presentation. We also anticipate that you will probably have lots of questions as we move through the presentation. So if you will, please use the chat function at the bottom of your webinar toolbar to ask those questions, and then we will actually field those to Mike at the end of the presentation. So now I want to introduce Michael Marr, who is our application technician here at Hoffman Group USA. He will be guiding you through today's webinar and the use of ToolScout. So Mike, take it away.
Thank you, Ashley. Good afternoon, ladies and gentlemen. Welcome to ToolScout 101 webinar. All you need to know to get started with ToolScout. Okay. There we go. My name's Michael Marr. I'm an applications technician with Hoffman. I've been providing technical support and sales support for CNC machines, cutting tools, metrology, and work holding products to a variety of customers: aerospace, automotive, medical, and woodworking customers. Been doing this a long time, since the early 80s, 35 plus years. And I've been with Hoffman USA since 2016. As you folks know, Hoffman's a global systems partner to industry worldwide. We've been providing quality tools for over 100 years. And again, welcome to ToolScout. This is the first of a webinar of hopefully a few webinars we'll do on ToolScout, and this one will focus on tool selection. Today I've just got a simple example of a drill and tap application. We're going to be challenged with tapping and drilling some D2 material. Some of you folks may recognize these callouts. Here is the steel number 1.2379. We have a thread size of M10 by 1.5 with an ISO 2x 6HX tolerance. And you can see here on a tap drill chart that we need an 8.5 millimeter diameter hole to generate this thread form. What you're going to learn today is using ToolScouts to select tools for this application. And in doing that, we'll look at this in a number of different ways, basically three hats, if you would. One would be a maintenance application, where just a maintenance guy or gal is challenged with one simple hole, tapping it. Another scenario would be a job shop where we have a small part run with this feature. Another scenario would be a manufacturing engineer looking to make a lot of holes and a lot of threads and looking for the most cost-effective solution. So we'll utilize the filters we have in ToolScout to help us narrow the tool selection. We'll also have a chance to review the application data for the tools, and then we'll analyze this data so we can make cost-conscious tool selections based on how the tool is being used. So without any further ado, we're going to jump in here to the web page. You're welcome to join me. But basically, we'll start off with our Hoffman web page. You'll need to be logged in here on My eShop. You can see that I'm already logged in. And you'll click onto the Service and Tool Services and select Garant ToolScout. That'll pull up the Hoffman Group ToolScout page. You'll have three options here. One is called My ToolScout. You're logged in. You can basically keep all the data, the cutting speeds, the information about the tools on My ToolScout. It's your own personal library, if you would. Here we can get application data for any Hoffman part number very quickly. And here is the tool search icon that we'll use today. The first page you'll see here are basically a process selection page. So we need to select the process that we're doing. We're obviously doing drilling today, but you can see these other processes that are available to you, whether it's milling or threads or gauging or torque. We'll focus on drilling today. So we need to drill an 8.5 millimeter hole. So then what ToolScout needs is the material that we're machining. So we have a number of different ways to select this material. And you can see here on the right, we have material groups labeled by P for steels, H for hardened materials, M for the stainless steel family, S for special alloys, nickel-based, titanium alloys, K for cast iron. You have the N group of materials for non-ferrous materials, aluminum, brass, copper, plastics, CFRP, the like. So there's an extensive library of materials in ToolScout, and what we're looking for are tool steels. So we'll select the P group for tool steels, and we can display this materials in a number of different standards organizations globally. So as Ashley mentioned, we have folks listening in from all across the world. So you know, our friends in Italy, for example, may be interested in the uni call out for D2 tool steel, and we can select that and see that D2 in Italy is designated as X155 CRV molybdenum 12 1KU, or a D2 listed here as well. So again, we'll go back in here, we'll look at ToolScout. We can look at it by steel number, we can look at it in a number of different standards organizations. And for North America, we're going to pick out AISI/SAE, which is the American Iron and Steel Institute, or the Society of Manufacturing Engineers. And you see the D2 material comes up. We can always verify that by hitting the I icon, and we can see the material listed by all those different material designation standards organizations globally, whether it's Britain, whether it's Italy, whether it's the steel number, whether it's a Japanese industrial standard. Here is France. Here we have the Asian Euro standard, or even the Czech Republic. So we'll continue on, and we'll basically see that we have a number of different choices for hole making, and we're interested in standard drilling. We need an 8.5 millimeter drill, so we'll type that in, select it. Depth of the hole is 20 millimeter. Here we can put in an additional length if we need to clear a feature on the workpiece. We're not concerned about that today. And we have here an option to enter cutter tolerance. This is actually the tolerance the drill will manufacture that hole to. We're not interested in that. We just want to look at all the 8.5 millimeter drills we have for this M10 by 1.5 tap. So that takes us to the next screen, which is details of all the tools. 59 tools have been selected. And now we're going to use filters to basically minimize the number of choices we have. I'll move this one icon out of the way here, but basically what we'll focus on from a maintenance standpoint, as we talked about in the PowerPoint, maintenance guy is not interested in making a lot of holes. He's just looking to fix the fixture. So we just want to sort the tools by looking at the high-speed steel options. So he quickly has used that filter just to focus out the tools that are high-speed steel in terms of their manufacture, and that's eliminated us down to 4 hits. We can look at those tools as a group by selecting them. And look at it as a PDF. So now the maintenance guy has, or gal has, listed tools, description, flute length, coatings, DIN spec to the standards the tool was made to, and a spot for the price. So quickly he's been able to look at those tools. We can look at these even further from an application standpoint. We can see this tool will run a lot faster than the others. Being a maintenance, maybe we're not interested so much in productivity as we can look at cost effectiveness as well. So we can look at the cost effectiveness of this tool. We see metal removal rate in cubic centimeters per minute. So this tool here is obviously the fastest metal removal rate tool that we have to offer in high-speed steel for D2. We can look at the product details for this tool. The maintenance guy can look and see that this is a powdered metal drill, and it's in bold here, very good for these materials, good for stainless, good for cast iron. Maybe he wants to look and compare it to another drill. Here's one with a Morse taper shank. So if he's got a Morse taper solution in the MRO shop and needs that, he's got that drill to choose. Or maybe he's just looking at a tin coated solution. He can look at this drill, see the price, description of the tool, and then see that this is in bold and is a better tool for more materials and maybe a better solution for the maintenance guy as he's tasked with other materials on a daily basis. You see here uni is checked for universal materials solution. So we go back and we look at ToolScout, and now let's look at this hit list, if you would, based on a job shop. It saves the data from the previous entries. And again, the 59 hits. And our sales guy at Hoffman has told us that Holex is a very good line of tools focused on job shops. So now we can just look at the Holex tools. We have 17 hits. You can see that it's eliminated the high-speed steel solutions and focused on carbide. We want to just focus on the high-performance cutting tools. We can use this filter. And then being a job shop, we want to look at coolant through solutions. And this particular job shop manager knows that he is looking for straight shank tools versus a flat or a whistle notch, as he's going to run the tool in a collet, let's say. Then he can quickly see that he has Pro Steel drills, and he can compare the two, look at the data, speeds, feeds, cost effectiveness. We can always punch in here this for job shop and production engineers, regrind costs, the number of regrinds for a drill, typically maybe 2 to 3 regrinds, the service life of that tool, and further analyze the cutting tool from a performance standpoint. You can see here we have a much higher metal removal rate than the previous high-speed steel tools selected. And the orange represents the portion of the tool cost. The blue is the proportion of the machine cost. So both of these are cost-effective ways that will remove 38.25 cubic centimeters of material per minute. So now let's take a look at this same scenario from a production standpoint. So a production engineer is looking for the most holes, the fastest. So we can use what we have here, a filter with a slide bar. So we can simply move the slide bar and just focus on our highest metal removal rate tools. My slide bar is giving me a little bit of a There we go. So now we focused just on the high metal removal rate tools. You can see this is focused now only on the Garant line of tools. We have two lines, Garant, Holex, Garant being our premium line of tools, all carbide, all high performance cutting. We're going to focus on the coolant through solutions. And this manufacturing engineer has heat shrink or collet holders. So he wants to eliminate any of the tools with flats or whistle notches. And now we have 6 hits of our highest performing tools to do this feature. So we can look down and we can see we can look at those as a PDF. We can look at the tools. We can see the same links here, longer tools. We see speed, feed drills. These are Hoffman innovations that are high performing tools. We'll go back to that list. He could send that list on to purchasing. We can sort these tools by metal removal rate. So we can see here that now we've sorted them from top down on the highest metal removal rate solutions we have, and the speed drill comes up as the solution. Knowing these speed drills are 2 different links, we'll just skip the longer drills and just do a little comparison here of all these high performance tools, looking at the application data. So the manufacturing engineer can see here, this one is a lot higher cutting speed. Feed rates are very close. Product details quickly can be accessed by just clicking on the product details page. Cost effectiveness is at his fingertips or her fingertips as well. You can see we're removing a lot more material with these tools per minute, double what we were on the Holex solutions. So we can look at product details, and this manufacturing engineer can look at this tool, look at the price, get a description, see the materials that it's good for, and maybe compare it to the feed drill. And see that the feed drill here is a 3-flute drill, maybe better for stainless. Maybe he has another job with stainless, and that might be the selection over the speed drill. Both of these would be very good tools. So now let's go back and look at this process from a thread standpoint. So you can see here we're going back to process with a quick click. We'll go to next screen is asking for material. ToolScout loves the steel number, so you can type in the steel number. You can see the same designation as we did before. Material designations in all the standard organizations globally. Potential strength of the material, hardness of the material is listed there. So continue. We have that material selected. And now we need to tell it thread tapping, forming, milling. We're tapping threads today. And then it's going to have a series of questions that it needs answered. M is for the M thread form 10. M10, we enter 10 millimeter. We want a right hand thread. We want a through hole. So you can quickly click on these, 20 millimeter on the thread depth. And here we have the option to put in the tap tolerance. Tap tolerance here is an ISO 2x, 6x. Typically you see this, this call out on more difficult to machine materials like D2. So now we've got 12 hits on a tap, and again we have a filter bar here that we can use to filter. So the job, again going back to the hats that we're wearing, the maintenance guy is looking for just taps with a plain shank, just looking for basic high-speed steel tap to do this job, and he can quickly look at these two taps with that ISO 2x tolerance and look at the application data for those, the cutting speeds. Look at the product detail for those. You can see that this tap, red ring, good for harder materials. Go back to look at the other tap, another red ring tap. Make an educated solution based, selection based on, this one can do a little lesser tensile strength materials, maybe a more universal tap for the maintenance guy. So now we'll go back to this hit list for tapping, and let's look at it a little differently from a job shop standpoint. And again, we'll focus on the plain shank solutions. It's got us down to 8 hits. We can see a lot of different taps here. We can obviously go to the PDF, look at the description of these taps. These are minimum order. These are special taps, really not in play here, but we have all the other sizes of all the other tap offerings. They're coatings, tin coated, aluminum, titanium, X coated, X being a special, titanium carbonitride coated. All those descriptions of the taps are listed. We can compare the taps. By selecting those, and then do a application data comparison. Compare speeds. We can see here from a product detail that this master tap with internal coolant may be a good tap for the job shop, for long lasting tap, or the standard non-coolant through master tap at a lower cost, and a very, very good innovation from Hoffman that will handle a lot of different materials. So an excellent selection for a job shop for this feature. Now we'll go back and look at this same application from a production standpoint. Production engineer wants to do this using rigid tapping. Synchronized spindle rigid tapping. And he can compare the performance and features of these taps. PDF on those, descriptions, borehole diameter for those taps, the price, and the application for those tabs. They all have the flat on here so that they're designed for rigid tapping, so a side screw can go in to hold the tab and not rotate during the process. But here you can see speeds and feeds are very, very similar. So being good manufacturing engineer, he can see red ring, green ring. He can compare the taps and make this a selection based on maybe other jobs that he's challenged with in the shop. You can see the materials that this tap is good for. You can see that it's not a coolant through solution. And you can compare it, let's say, to this other green ring tap, which is the same tap with coolant through. The coolant through comes at the end of the tap to help blow the chips out and keep the process stable. You can see all the different materials that that tap's good for. Well, ladies and gentlemen, that was a very quick run through of how to select a drill and tap for a given application and using the selection tools that we have in ToolScout. Look forward to answering any of your questions and having other ToolScout webinars here in the future. Thank you.
All right, thank you, Mike, for that. We did have one quick question that I answered in the chat, but I wanted to make sure that everybody saw it. The question was, can you use ToolScout without an account, or do you have to create one? The answer to that is yes, you do have to have an account. You can go to toolscout.com/mytoolscout to set up your account, and we will actually send out that link in a follow-up email to the webinar as well. So if anyone else has questions, please ask them at this time. We'll give everybody just a couple of minutes, see if we have any more. All right, so we do want to be respectful of everyone's time. So while I'm finishing out here, I'll give everyone a couple more minutes just in case there are questions. But at this time, we will conclude the webinar unless we have any other questions. If you missed a portion of the webinar or you came in late, we will be sending out the link to it, but it can also be found at hoffmangroupusa.com. Also be on the lookout, as Mike mentioned earlier, for our next in this series of webinars. It will be in probably middle to late June. We will send out the date and the time in our regular monthly e-newsletter, and it will also be posted on our social media channels very soon. Again, we want to thank you for attending this ToolScout 101 webinar, and we hope everyone has a great rest of the day. Thank you, guys.